Okay, it's about 24 degrees outside right now in Mississippi, and I know some of my northern friends are probably laughing right now, but 24, that's kind of cold for us this time of year. We normally don't have highs in the 20s during the daytime, but looks like the first part of the week is going to be an exception. But anyway, I'm out here in the shop with the little heater on. And what we have here today is a pile of old capacitors. Some of these are mica capacitors, and some of these are actually paper capacitors and that look like mica capacitors. Now, I've heard some people say that, oh, mica capacitors rarely ever go bad. Well, that might have been true in the old days, and to some degree it might still be true, but they can go bad, as I will demonstrate. I actually have both of my capacitor testers fired up and ready to go. We have the old Heathkit tester from around 1950 and the ICO tester from around 1963. Just a brief overview of the leakage test function on these two testers. This model uses a neon bulb, and on the leakage range you apply various voltages to the capacitor, and if the neon bulb steadily flashes or glows, then the capacitor is leaky. On the ICO tester, leakage is indicated on the magic eye tube, and we have a continuously variable voltage source for our leakage test. And if the eye closes and remains closed, then the capacitor is leaky. Okay, the first capacitor we'll check is this 0.01 microfarad mica condenser, and it says right on the case, mica condenser. So unless they lied, this is not a paper cap inside of a plastic case. First we'll check it on the Heathkit condenser tester. Applying 25 volts, well actually it's probably a little more than 25 volts, but you see the light blinking like crazy. And as we increase the voltage, the light blinks even faster until it just gets to a point where it just stays on all the time. So that capacitor is very leaky. Now we have the same capacitor connected to our ICO tester, and I will gradually increase the voltage while you watch the tuning eye. Look at that. And we're only applying about a little less than 100 volts. So yep, that capacitor is very leaky. Here's another mica capacitor, 0.004 microfarad at 2500 volts. At 600 volts, it's leaking. Not as bad as the first capacitor we tested, but still leaky. And the same cap on this tester appears to be okay on this model. But I think this little Heathkit tester might be a little bit more sensitive to leakage than this one. Here's an Aerovox 0.004 microfarad. Not sure if this is mica or a paper cap, probably a paper cap, but you can see it's leaking like crazy on the lowest voltage setting. And now the same cap on the ICO tester. Pretty much the same results, leaky like crazy. Here is a 0.01 microfarad Sangamo brand mica condenser as labeled on the case. I'd say that's pretty leaky. And now the same capacitor on the ICO tester with minimal voltage applied. So yeah, I'd say this one is very, very leaky. Here's another identical mica condenser connected to the ICO tester. Leaky as all get out. And the same cap on the Heathkit tester. Here's another mica capacitor. Can't quite make out the value, but it's rated at 2500 volts. As you can see, it's also leaking. And if you were to use this capacitor at closer to rated working voltage, it would sure enough leak. As you can see, as I raise the working voltage, the more it leaks. Same capacitor on the ICO tester. And here's a disc cap that for some reason last night was showing a tad bit of leakage on the Heathkit tester, but now it appears to be okay, so I really don't know what's going on with that. Maybe something to do with the temperature change. As you can see, the light is not blinking at all, and we're on the highest working voltage setting of 600 volts. Here's a Sprague capacitor. Not sure if this is a mica, but it looks like it could be a mica. Whatever it is, it's highly leaky. And I'm not going to test it on the other tester because the ones that seem to be this leaky on this tester have always showed up very leaky on the ICO, so just save a little time here. And here's a 10,000 picofarad capacitor, likely a mica. Very leaky. Here's an Aerovox cap, not as leaky as the others, but it's 600 volts. We're showing some leakage. Now these types of caps might be okay for use in lower voltage circuits, but still, anything that's leaky, I really don't trust using them in anything. Now here's a mica mold cap. Now the name would imply that this is a mica cap, but that's not the case. This is actually a paper cap that looks like a mica cap and is named like a mica cap, but Mica Mold was simply the company that made the capacitor. And they are notorious for leaking, as you can see. Now here's another known mica capacitor of the type you might find in the average radio, and I'm applying 600 volts to it for a leakage test, and as you can see, the light is not blinking. So as far as I'm concerned, this one's okay, and I wouldn't mind using it in something. And here are a lot more of those various types of capacitors in this drawer that I have not tested yet. And here's a 47 picofarad capacitor that seems to be good, no light blinkage. Here's a more conventional looking Cornell Dubilier mica capacitor like you might find in a tube radio. Not good. And the same capacitor on the ICO tester. Look at that, leaky like a sieve. Okay, so the point of this little demonstration is to illustrate that mica capacitors can indeed fail. As you saw in this little demonstration, some of these capacitors tested perfectly okay, while other ones leaked like crazy. So the moral of the story is they can go bad, and if in doubt, test them. And like with paper capacitors and electrolytic capacitors, you really need a capacitor tester like one of these that will actually apply a high working voltage to the capacitor in order to test it. These little modern handheld digital meters don't apply enough voltage to accurately test a capacitor for leakage. Just for the heck of it, here's an Elmenco .0022 microfarad 600 volt ceramic cased tubular paper capacitor from the 60s, and as you can see, it's leaking badly. Okay, there you go. My little demonstration on testing mica capacitors and the fact that they can go bad. Thanks for watching, and more to come later.